let's learn about quadratic word problems. So we're going to do some that have rectangles, some that have just numbers, and some that have gravity. Then you'll do some class practice with your delta. So here we have the length of a rectangle is one more than the width. So let's draw the rectangle. Usually the length is longer. The length of a rectangle is one more than the width. So I don't know the width, so I'm going to call the width x. And if the length is one more, it's going to be x plus 1. I'm told that the area is 72 square units. So remembering from geometry that area formula for a rectangle is area equals length times width. So I'm going to plug in what I know. 72 is my area. My length is x plus 1, and my width is x. I'm going to multiply on that right side and distribute, so I get x squared plus x. And now I see it's a quadratic with the x squared, but right now it equals 72, and I want to solve it, so I want it to equal 0. So I'm going to subtract the 72, and I get x squared plus x minus 72. That's a quadratic trinomial that is ready for factoring. So we're thinking about what multiplies to negative 72 and adds to 1. That's going to be 9 and negative 8. So I'm going to write it in factored form, x plus 9 and x minus 8. That's set equal to 0, so I'm going to use the zero product property to set each equal to 0 and solve. I get negative 9 and I get 8. But negative 9 doesn't make sense, so I'm going to say that the width is 8, but they want to know the length, so when I plug that in, the length is going to be 9. Let's try another one. So I'm going to start with my rectangle. This time we have the width of a rectangle is the length minus 3 units. So I'm going to call my length x and my width x minus 3. My area is 54. So area equals length times width. Now we have the 54. Our length is x. My width is x minus 3. I multiply out that right side. Subtract the 54. Let's factor it. What multiplies to negative 54 and adds to negative 3? That's negative 9 and 6. So we get x minus 9 and x plus 6. Set each of those equal to 0. X could be 9, but x cannot be negative 6. So when I plug it back in, the length is 9. The width is 6. So make sure you're answering the right question. You're not always going to come out to the variable being the answer, so you have to interpret that. Here we have the number types of problems. 7 times a number is 8 less than. We have to be careful of that. We have to switch the order there. Then the square of a number. Find the negative solution. So pay attention. Sometimes they'll ask you for positive, or sometimes they'll ask you for negative. So I'm going to let x be my number. So 7 times a number. 7 times x is my equal sign. 8 less than means I'm going to switch the order. The square of a number. So that's my number squared. And then I will do minus 8. So it's not in standard form. I'm going to subtract the 7x so that it is then set equal to 0. So I have x squared minus 7x minus 8. We'll factor that. And that's going to factor with negative 8 and 1. Set each of those equal to 0 and solve. So I get x could be 8, x could be negative 1. They want the negative solution, so we're going with negative 1. 6 times a number is 16 less than. 6 times a number is 16 less than the square of the number. Find the negative again. So I'm going to subtract that 6x over, put it in standard form. Oops, subtract. And then we're going to factor negative 16, negative 6, negative 8, and 2. So that goes to x minus 8 and x plus 2. Therefore, x could be 8, x could be negative 2. We want the negative answer. Now, let's look at some gravity types of questions and say we're launching a rocket. So you see that it goes up and it comes down. We also can see that we have a y-intercept here at 4. So that must be my starting point. I have my vertex. This would be 1 here because this is 2. So my vertex is 120. Now this bottom is the time, and my y-axis is the height. So that means in 1 second, it got up to 20 feet high. And then the 2 is my x-intercept, and that means it took 2 seconds to hit the ground. So when you're doing these types of questions, you might see, what is the time to hit the ground? That's this answer. Here's the ground, this is the time. What's the time at the maximum height? This is still time, so this is x of the vertex. And then what is the maximum height? That's y of the vertex. So we can look at it like that. So what are some things that might affect the rocket as it's launched? That could be gravity pulling it down, velocity, how fast it's going, and then the A value, which it's going to go down and come up, so we know the A value is positive. So this is our thrown model. You should write this down. H equals negative 16 t squared plus vt plus s. So let's look at what each of those means. Notice that the 16 is negative. That negative 16 is always going to be in there, and it's negative because the parabola is opening down. The 16 is due to gravity in feet per second. The t is time, the v is velocity, that's usually going to be given, and then s is the starting height. That leaves h to be the ending height. So here we have a rocket. It's launched from a tower. The height is in feet. The time is in seconds. What do we know? So this is our gravity. This is our velocity. This is our starting height. So I'm just going to sketch a little bit here so we can get it. So it starts at 116. It is negative, so it goes up and comes down. That's what we're thinking so far. We know it opens down. The velocity is that. It starts there, and I just drew a sketch. We want to find the time it takes to hit the ground to 2 decimal places. So the time that it takes to hit the ground is over here. This is an x-intercept. And when we're trying to find an x-intercept, we could factor, but you can see that these numbers are a little bit ugly. So we're just going to go straight and do the quadratic formula. I'm going to do it out for you, even though I showed you the answers. So x equals negative b, negative 248, plus or minus 248 squared minus 4 times a, which is negative 16, times c, which is 116, all over 2 times negative 16. Don't drop that denominator. Remember, we start by figuring out the discriminant. So that's a lot. Do this piece on the calculator. 248 squared is 61504. And then the less part here, that's a minus a negative, so that's going to be plus 7424, which is the square root of 68928, which when I hit a decimal is 262.5. That is my discriminant. So I'm going to put that together. We're going to do negative 248 plus 262.5 divided by negative 32, and negative 248 minus 262.5 divided by negative 32. So then you're going to get a negative 0.45, which we're not going to use, and you also get the 15.9. Here we're asked, when will it reach its maximum height? So if I think about this as a different equation, so that my starting height is 148, goes up, it comes down. This is time, time is when. So I am looking for x of the vertex. Well, it's in standard form, so we know we can use x equals negative b over 2a. X equals negative 163 times 2 and negative 16. So that becomes about 5.09 seconds. In about 5 seconds, it's at its maximum height. When, oh, we already did that. We'll walk all the way through this. And here we go. So now, what is the max height? Again, a new problem. We're starting here at 139, going up and coming down. What is the maximum height? That's y of my vertex. So first I have to find x of my vertex. So x equals negative 12 over 2 times negative 16. So x is 6.625. Then you're going to plug it back in. And remember to square this first, square that number, multiply it by a -16, and then go through the whole process. You get 841.25 feet is its maximum height, which if you remember was about 5 seconds. Oh, that's a different problem. So we did that as the y of the vertex. So to recap, when you are finding when it hits the ground, that's your x-intercept, and you can either factor or quad formula. When is it at its maximum height? That's your b, and so that is x equals negative b over 2a. And then to find y, you're going to plug in that x. And now it's your practice time. Good job.